So last video we talked about graphing rationals and we talked about finding the horizontal asymptotes. Now we need to be able to find the vertical asymptotes. So that's another piece of this puzzle. So this green line right here, this is our vertical asymptote. So that's what we're finding. So let's look at this function. So we have x plus 3 in the top. We have x squared plus 6x plus 8 in the bottom. We would also find the horizontal asymptote for this, but for this video, we're just interested in the vertical asymptote. Well, in order to do that, we need to factor the bottom first. We need everything in its factored form. Okay, so the top one is already in its factored form, so this just stays x plus 3. The bottom part, though, we could factor that. So this is going to be... So we're going to factor this like we normally would. So we have our a, b, c. I'm just going to do this super fast because you already know how to do this. So this is a 1, this is a 6, this is an 8. 1 times 8 is 8, so we have 8. We have the factors of 8 are 1 and 8, 2 and 4. And this is going to be the one we want. So our factored form of this is going to be x plus 2, x plus 4. I know I went through that super fast, but we've been doing that for a little while now. You should already know how to do it. If you don't, look back through some of our past videos. I'm sure that we have a factoring one in there somewhere. Okay, now we have a factored form of this equation. If you notice, neither one of these two in the bottom cancel out. This is just, we're left with x plus 2 and we're left with x plus 4. The way you tell if something is a vertical asymptote, so okay, vertical asymptotes and holes all have something to do with the bottom because you can't divide by 0. So cannot divide by 0. So if there's any x in the bottom that's going to turn that into a 0, bad things happen. So, okay, we say, well, surely something could make that be a 0. So if we have x plus 2 and we have x plus 4, if we set those equal to 0, we'll be able to find the x's that we can't have, right? So we have x plus 2 equals 0. We're going to set these to 0 independently. So that one will be there, this one will be here, x plus 4 equals 0. We solve for x, we get x equals negative 2. Over here, we subtract our 4, we get x equals negative 4. So we have vertical asymptotes in this case for x equals negative 2 and at x equals negative 4. These are both vertical asymptotes. So basically, your vertical asymptote is a factor in the bottom that doesn't cancel out. Let me write that down, that's an important one. Okay, so I have that written here. Vertical asymptote is a factor in the bottom that doesn't cancel out. So looking at these three examples in the yellow one, so we have x plus 2 over x plus 3. This x plus 3 didn't cancel, that's going to be a vertical asymptote. And where it's going to be a vertical asymptote is, we're going to set it equal to 0. We solve for x. So we have a vertical asymptote at x equals negative 3. So vertical asymptote at x equals negative 3. I'm going a little bit quickly here, but you could always stop and rewind. Okay, in this one, we have two factors in the bottom. Now notice I've already changed all of these to factored form, just to go ahead and save us some time. So we have an x plus 3 in the top. We have an x plus 3 and an x minus 1 in the bottom. These x plus 3's cancel with each other. So that leaves us a 1 up here. But we're still left with this x minus 1 in the bottom. Now something happens with this x plus 3, but it's not a vertical asymptote. The only one that's left over is our x minus 1. So that's where our vertical asymptote is going to be. So we go x minus 1, we set it equal to 0. We solve for x. So we have a vertical asymptote at x equals 1. Vertical asymptote at x equals 1. For our last one, so we have a 1 in the top, and we have two factors in the bottom. So that means both of these are going to be left over, and neither one of them cancels out. So we got to solve each one separately. X minus 5 equals 0. X plus 2 equals 0. So if we solve, on this side we get an x equals 5. On this side we get an x equals negative 2. So we have two vertical asymptotes. We have a vertical asymptote at x equals 5 and at x equals negative 2. So that means you're going to have two vertical lines that your function doesn't touch. So that's all there is to vertical asymptotes. Basically, you factor, you cancel anything out that you can cancel out, and whatever's left over in the bottom, that's your vertical asymptote.